Good morning. Okay, my name is Calvin. So I'm from JS Denki. So our company is mainly focusing on supplying test and measurement equipment for EMC test solution. Okay. Okay. So this demonstration is a very basic demonstration about radiated emission. So in EMC measurement, okay, we mainly cater for emission and immunity testing, okay, which is the noise that is being produced, generated by the equipment under test. Okay, so today we'll focus on two tests, okay, which is radiated emission, okay, which is the noise that we measure, and also in the immunity, we want to show you the ESD simulator, okay. So here, okay, we have a spectrum analyzer. In EMC measurement, we usually use a spectrum analyzer or EMI receiver. Okay, depends on the frequency range that you want to measure. So here we have a Cong generator, which is a noise source. Okay, so it will generate noise, okay, 30 meg to 1 gigahertz on this model. So we just simulate one antenna over here. So the antenna will receive the signal, okay, from the noise radiate from here. So from here, you can see this is the environment noise around this area, okay? So when I power on, okay, so you can see additional noise that is being generated from this device, okay? So if I move nearer, you can see the noise is getting bigger, okay? So this is just to simulate the noise, okay? So from here, okay, so we want to measure the noise from this. So imagine this is your equipment under test, okay? So from the software, so we will use Toyo EMC software. Okay, so this is the radiated emission software that we use normally in control environment. So the control environment for typical measurement is in an anechoic chamber. Okay, so in the anechoic chamber, so we control the antenna mass. Okay, typically we move 1 meter to 4 meter, and then we rotate. Okay, we rotate the turntable. That means we rotate your EUT 360 degree. Okay. So we'll start to do a simple measurement. So I will create a new data. Okay, so now I want to measure this, okay, noise. Okay, so I will run the software. Okay, so the frequency that I want to scan now is 30 megahertz. Okay, so a 30 megahertz to 1 gigahertz. Okay, so I set this frequency range that I want to measure. Okay, so the spectrum analyzer will go on the setting based on the setting in the software. So it will imagine the turntable, it will rotate 360 degree, and now it's in the simulation mode. Okay, so I'll measure the noise, okay, across the 360 degree of the EUT. So after it turns 360 degree of the EUT, then I will plot this graph, okay, into the measurement software. Okay, so wait for it to turn. Okay, so just a simulation, it will turn. So after it finished turning, okay, then whatever is captured now, okay, it will be plotted in the software. Okay, so maybe you can come nearer to the software, then you can see. Okay, so this is the graph, okay, that is being captured over here. So being exported in the software. So of course you can see the red line over here. Okay, this red line is the standard limit. Okay, so it depends on which product standard you follow. For example, now I set it to SCETPA 32, which is for multimedia device. Okay, if the device is household appliances, so you can set the other limit, okay, to SCETPA 14-1 or others. So from here, you can see, okay, which are the levels that exceed the limits, okay, in EMC standard, okay, for example, in SCETPA, when you want to do CE testing, okay, you want to get a CE confirmation, okay, you need to make sure that your device under test falls everything below under the limit line, okay, which is, for now, is a SCETPA 32. So for here, now I know that a few frequency here, okay, so I can zoom in into here. Okay, then I can select the point over here. I know that, okay, 89.995. Okay, this exceeds the limit. Okay, so exceed the limit. But of course, now we are in the open environment. This is actually a FM noise. This is not an actual noise. Okay, so, okay. then I know this level is exceed the limit. Of course, then I want to know in a SCETPA standard, this is a peak level, okay? We want to know the quasi-peak and average, okay? So we will go further for a quasi-peak measurement, okay, to determine what is the level of the QP and AV of this measurement, okay? Then you can categorize your product pass or fail, okay, after the EMC measurement. So this is only one part, okay, of the emission testing, because in the emission testing, of course, we have many other testing that you require. For example, in RF, we only do radiated emission. So we still have a conducted emission. We still have non-RF, which is like harmonics and flicker. Okay. Then, of course, in immunity, we are doing the opposite of the emission. So just now we measure the noise that generated from your product. Now I want to see whether your product can withstand the immunity or not. Okay. So in here, this portion, I will inject RF, okay, to your product, okay, in a controlled environment, of course. And also the ESD surge burst magnetic field, okay, so we inject high voltage to the product. So here, okay, we have a ESD simulator, okay, from EMC partner. Okay, so this device can generate up to 30 kilovolts. Okay, so we will inject the high voltage, okay? So we will inject the high voltage to the product and to see whether your product can withstand the test level or not. So the test level, of course, defined by the product standard, okay? Different product standard, okay, like SCETPA 35, okay, calls for different test level, okay? So just a simulation, okay? So we can come here. So now, for example, okay, I have 25 kilovolts, okay? So of course, I cannot shoot to the environment because it will disturb the rest of the device nearby. So maybe I can do a brief simulation. For example, now I want to inject a 25 kilovolt. So probably you can hear, you can see, okay? So maybe some small spark, okay, on the fork. Of course, in actual, I need to test on the device under test. So this is just a brief simulation, okay, on the ESD. Okay, thank you.